Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to take a look at the unit circle and the way that we can really memorize it without having to memorize the unit circle. So typically we know that unit circles start off in this quadrant one. This is typically 0 degrees or 360 degrees. We know that this creates a 90-degree angle because we see that that's a 90-degree angle. We know straight lines are 180 degrees. Then we've got 270, and then we've got 360. A couple of things we also know is that this point is 0.10. This is 0, 1. This is -10, and this is 0, -1. So these are going to be helpful later on for finding out sine, cosine, tangent, things like that. But for our purposes right now, we understand that this circle is a whole unit. Okay. So I'm going to start off with, maybe I'll just do red, to create a line that kind of goes in this direction. And then I'll do another line. Get rid of that. That goes in this direction. And hopefully these will kind of create, yeah, hopefully these created some sort of 45-degree angles. I feel like this one might not quite have created a 45-degree angle. Just a little bit better, I think. Yeah. Okay, so with a 45-degree angle, what's happening is that first and foremost, let's actually make these a little bit smaller so that we can write some stuff. Let's make this a little smaller. Okay, much better, much better. So this is a 45-degree angle, not 450, 45. This, so if I count my unit circle in terms of 45-degree angles, this will be 45 plus another 45 is 90, plus another 45 is 135. Another 45 is 180, another 45 is 215, then 270, and then 315. So this, sorry, this is 225, not 215. 225 and then 315. Beautiful. Okay. So I've just counted my unit circle in terms of 45 degrees. I also know that in a typical 45, 45, 90 triangle, my sine and cosine are the same because when I go in here, we're going to make pretend like these are 45-degree angles for both of them. I know that this is n, n, and n root 2, or I can replace the n with 1. So I can go, this is 1, 1, and root 2. So my sine of a 45-degree angle is going to be 1 over root 2, which I know I can't have. So I'm going to multiply by root 2 over root 2. So I'm going to end up with root 2 over 2. And same for cosine. Cosine is going to be adjacent over hypotenuse, which is 1 over root 2, which then transforms into root 2 over 2. So I know that this point will actually be root 2 over 2, comma, root 2 over 2. Now, a couple of things that I want to mention is your sine and cosine will actually be x and y. So for example, my x and y coordinate point is going to be cosine sine. And one of the ways that you can remember it is that it's all alphabetical, right? So x comes before y and c comes before s. That's all we have to remember. Now, when I'm looking at this particular point, I know that this is kind of just the reflection. So, excuse me. So this is a negative root 2 over 2, comma, root 2 over 2. Because the only difference is that the x is negative here and the y is still positive, right? Here, everything is negative. So we're going to just put negative root 2 over 2, comma, negative root 2 over 2. And this point right here, the x will be positive. So I'm going to have root 2 over 2. comma negative root 2 over 2, because the y is negative down here. And it's all about understanding that you have this very first angle or this very first sine cosine point. And then it just reflects, reflects, reflects. And so you're just changing either the x or the y coordinate. Okay. The other thing that I want to make sure that we talk about before we continue on is our radians. So typically we know that 180 is the same thing as 1 pi, right? So that means 260 is going to, sorry, 360 is going to be 2 pi. I know that half of a circle is a whole pi. So half of half, right? Or half of pi, right, is going to be pi over 2. So if this is a whole, this is half pi over 2. This would become a quarter. So this would be pi over 4. In case you can't tell, right? So for example, I have 1, 2, 3, 4 quarters here. These represent my 4 quarters, and those 4 quarters add up to 1 whole pi, right? So on my red lines, I'm going to count by pi over 4. So this is 1/4. This is 2/4, which actually translates to 1/2. This would be 3/4, so 3 pi over 4, and then this would be 4/4. Down here, we're going to continue into 5 over 4. This would be 6 over 4, but 6 over 4 can translate into 3 over 2. And then I have 7 over 4. And then I have 8 over 4, which is exactly the same as 2. So these are my 45-degree angles. Now, one thing that we do want to make sure we understand is that the unit circle doesn't stop at just these angles. So one thing that we know is that we actually have a 30-degree angle and a 60-degree angle. So I'm going to go in and I'm just going to create these lines and hope that I can draw them a little better. Let's see. No, that one's not so bad. And then we'll have another one here. And recently, one of my students actually said that this is kind of like a firework or an explosion of math. And I don't hate it. I don't hate it. So we're gonna go with that. It's an explosion of math. One of the things that we're gonna do right now is we're gonna break this up. So I know I have 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Not a fan of this 8. So with the way of explaining it. So let's take a look at this. This is a 90-degree angle. I know that this 90-degree angle is going to be divided into 3 equal sections. It does not look like it's 3 equal sections in this case, but we're going to say that this is a 30-degree angle. This is also a 30-degree angle, and this is also a 30-degree angle, right? So then if this is 30 degrees, this next one is going to be 60 degrees. The reason why it doesn't look like that is because I need more space to write. But on a typical unit circle, you'll see that these 3 are a lot closer together than what I have in here, okay? So if I'm going to count by 30s, I'm going to go 30, 60, 90. And I'm just counting the blues because the reds are all 45s and 30 is not a factor of 45 and 45 is not a multiple of 30. So after 90, if I add another 30, I get 120 plus another 30 is 150 plus another 30 is 180, 210, 240, 270, 300, 330, and 260. All of these now have a version of pi. So they have a specific radian. So if I take pi over 2 and divide it into 3 equal sections, I know I'm going to have pi over 2 divided into 3 equal sections. Well, I know pi over 2 is the same thing. Division of fractions is multiplying by the reciprocal. So I'm going to have pi over 2 times 1/3. So it'll be pi over 6. So if this is 90 and I'm dividing it into three equal sections, I get 30 degrees. So 30 degrees and pi over 6 is exactly the same thing. So this is going to be 1/6. When I double it, right, to get to 60 degrees, I'm going to have 2 over 6. And 2 over 6 is the same thing as 1/3. So this will be 1/3, 2 over 6, 3 over 6, which is 1/2, 4 over 6, which is 2/3. Then I go to 5 over 6. Then I go to 6 over 6, which is a whole, 7 over 6, 8 over 6, which is 4 over 3, 9 over 6, which is 3 over 2, 10 over 6, which is 5 over 3, and then, um, sorry, 10 over 6, 11 over 6, which can't be simplified, and then 12 over 6, which is 2 pi. So at this point, I've got all of my degrees and all of my radians on the graph. One thing I do want to point out is in this particular case, so what you'll notice is I go 30, 60, 90. So I go 1 over 6, 2 over 6, 3 over 6, 4 over 6. But I also can count by 60s, right? Because 60 is a factor of 360. So I can go 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, which is 2 whole, right? 6 over 3 is the same thing as 2. So in that particular case, I end up with that same pattern going on and on and on over and over and over in this circle. Now I do have to find my X and Y points. So in order for me to find my X and Y points, I need to go in to my original 30, 60, 90 triangle. We're again going to make pretend like this is an actual 30, 60, 90 triangle. So we'll do that. My 30, 60, 90 special right triangle has 1, √3, and 2. So if I want to find the sine of 30, I'm going to go opposite over hypotenuse, which is 1/2. If I want to find the cosine of 30, I'm going to go adjacent over hypotenuse, which is √3 over 2. If I want to look for sine of 60, I'm actually going to go adjacent. Sorry, adjacent over hypotenuse. No, sorry, sine is opposite. So √3 over 2. And cosine of 60 is adjacent, which is 1/2. One thing that you're going to notice is that sine of 30 and cosine of 60 is exactly the same. So we're going to use these two types of fractions interchangeably. Another thing that you'll notice is that almost pretty much everything is over 2. So we know that cosine of 30, so let's take a look back. Cosine of 30 is √3 over 2, and sine of 30 is 1/2. So this point here, I should probably use a different color. Let's do blue. So when I'm here, I'm going to have cosine of 30 is √3 over 2, comma, 1/2. I also know that sine of 30 is 1/2, comma, √3 over 2. So when I need to extrapolate what these 2 points are, again, all I'm going to do is I'm going to reflect them over. So I know that in here, everything is positive, but in here, we've got negative numbers. So this is going to have a negative X and a positive Y. Same exact thing as that, if you can tell, except this is a negative, this is a positive. Again, same thing for here. I'm going to have negative √3 over 2, comma, regular 1/2. And you'll see that these two are kind of flip-flops of each other. This point here is the negative version of that. So I'm going to have negative √3 over 2, comma, negative 1/2. Again, this will also be fully negative. So it'll be this point, negative 1/2, comma, negative 3 over 2. Then this one we're going to reflect onto here, and we're going to have positive x, negative y. Same business here, we're going to have positive x and negative y. So again, you're looking at reflections of everything and you're trying to follow that same pattern, okay? I hope that this was helpful in helping you memorize the unit circle, and I will see you in another video. Bye.